Welcome to our presentation. The topic of our presentation today is analyzing holiday season Twitter feeds in 2016. With the election going on in 2016, there are a lot of political turbulence. And when we first met, our team is very curious about the sentiment of this holiday season, given what's going on in 2016. Is it going to be filled with political talks? Having that question in mind, we went on going through the social medias that we could actually perform our analysis on. And as a result, we chose Twitter because Twitter is the favorite of our new president. We get our data from Kaggle.com. There are 29,624 tweets during Christmas Eve and Christmas Day. The data was laid out as two fields. The first field is Twitter ID, and the second field is HTML metadata. Actually, when we take a deep look at the data, it's not as clean as the author mentioned, so we did some data pre-processing.
First of all, we want to give you an introduction about how we pre-process our data. So let's take a look of the metadata of the tweets after downloaded from the Kaggle website. Each tweet is associated with an ID, but there are a lot of information that we wanted to get rid of. So we followed 5 main steps in this pre-process, such as parses and URL, remove the HTML tags, removed at, punctuation, numbers, links, tabs, also remove the retweet and unnecessary spaces, and also get only the XC characters. After the initial pre-processing, we would like to find the approach to better deal with the words sharing the same word roots. Stemming is an option because stemming can extract the word roots from multiple words that has similar meanings. But the issue here is tweets came from thousands of different users who probably have different expression habits, which means they're mad various transformations of the similar words. This will make the stemming function built in R cannot work effectively. The second issue in our case is users do not add white space between multiple words in hashtag, but because stemming is just simply disregards the words after the word roots, which will make us lose a lot of information when deal with the words inside hashtags. Therefore, we decided to manually change, separate, and merge the high-frequency words. In terms of high-frequency words, we means the words that appears more than 100 times across tweets. We give 2 examples at the bottom of this slide. The first one shows you how are we changing different words into the same one, such as celebrations, celebration, celebrating. They are all replaced by celebrate. And the second example show you how did we merge different words. So Donald Trump is replaced by Trump because they are referring the same person. Alright, after that, we remove the stop words using the TM package in R. We give bullets show you the 4 categories of the stop words we removed and also including the examples in each category. And the last step in pre-processing is transformation to the corpus format. So the corpus means a collection of documents in our environment. After this transformation, we could proceed our text mining process. Okay, so now we got the clean data and we would like to perform some exploratory analysis of our text. We would like to know what are the common words in tweets. So on the left bar charts, we give you a list of the words that appears more than 1,000 times across tweets. Christmas, no surprise, is the top 1 word, followed by Merry Christmas Eve, holiday, gifts, and the word cloud on the right side give you the frequent words except for Christmas. So the several most frequent words are Merry, holiday, Santa, Christmas Eve, gift, and it just gives us a feeling that they're all happy words, which is good. Next, we explore the term correlation in tweets because we have some terms in mind that are particularly interested. So we would like to identify the words that are most highly correlated with that term. Take Trump as an example. The MAGA is the word that co-occurs most with Trump, followed by China, Putin. And let's take a look of women. Free is the number 1, followed by Black Friday and deal, which is very interesting and also makes sense because we know that women are enjoying shopping and finding deals. So this is very interesting analysis because we could perform the same analysis to any words we are particularly interested. But we also wanted to give some notes about these slides. This analysis is just a measure of the frequency about which words show up together in across the documents. So it's not indicative of the frequency, neither an indicator of the nearness. So let's move forward to the sentiment analysis. So the sentiment analysis is generally help us to better understand the attitude and opinions across the text, such as is this generally positive attitude or negative. So we use tidy text package in R and we transform the format to tidy text format. There are multiple lexicons available for text mining. We chose 2 out of them. The first one is the NRC lexicon. It categorizes words in 10 categories: positive, negative, anger, anticipation, disgust, fear, joy, sadness, surprise, and trust. And Bing lexicon categorizes words into 2 categories, positive and negative. First of all, we want to show you how did we use an NRC lexicon to explore the word frequency in each category. The bar chart on the left shows you the frequency of words in each category. So the first one is positive, followed by joy, anticipation, trust, surprise. They're all kind of good. And the divide categories are all in right side. So all low frequent, negative, anger, fear, disgust, and sadness. Also, on the left side of the slides, we give a top 10 words in fear category. So watch, God, elf are the top 3. We could give this table to each categories we're interested. These slides show you how we use Bing lexicon to compare negative and positive words. The bar chart on the left side show you the top 10 words in both negative and positive category, and the y-axis scale are different for negative and positive, which can show you clearly that the positive words are much more frequent than negative words. and on the left side, we replot the word cloud to show you the frequent words in negative and positive category. So generally, we can see that the positive words is dominant in the Christmas tweets, which makes sense because Christmas is always a very happy holiday, and the ratio is about 85% are positive words. So we can further our analysis by comparing the sentiment of different holidays to find out more insights about what's the difference of sentiment existing in different holiday and time of period. All right.
So next, let's talk about topic modeling. In text mining, we often have collections of documents, such as papers or news articles. Sometimes we like to divide them into natural groups so that we can understand them separately. Topic modeling is a method for unsupervised classification of such documents, similar to clustering on numerical data, which finds natural groups of items even when we are not sure what we're looking for. LDA is a particularly popular method for feeding a topic model. It treats each document as a mixture of topics and each topic as a mixture of words. This allows documents to overlap each other in terms of content, rather than being separated into discrete groups in a way that mirrors typical use of natural language. LDA is a mathematical method for estimating both of these at the same time, finding the mixture of words that is associated with each topic, while also determining the mixture of topics that describes each document. One of the most common structure that text mining packages work with is the document term matrix, or DTM. This is a matrix where each row represents one document, each column represents one term, and each value contains the number of appearances of that term in the document. DTMs are usually implemented as sparse matrices, meaning the vast majority of values are zero. These objects can be treated as though they were matrices, but are stored in a more efficient format. DTMs are not tidy and cannot be used directly with tidy tools, just as tidy data frames cannot be given to text mining packages. We use TM package into R to convert the clean dataset into DTM. We see that this dataset contains documents, each of them an AP article and terms, distinct words. Notice that this DTM is 100% sparse. 100% of documents words pairs are zero. According to the topic modeling characteristics, we treat tweets as one topic, and this topic includes several words. Then we use LDA to get top 10 items in each topic. In the graph, we can see the most common word in each topic is Christmas. Other common words are really similar, which with each is holiday season. Each document appears in each panel in this plot, and lambda is for that topic tells us that the document's probability of belonging in that topic. There are many documents with lambda close to 0. These are the documents that do not belong to the topic. We believe the topic modeling resulting is not as fruitful as we have expected. Topic modeling works the best with a document that contains many files, which contain many topics. However, in our situation, we have a file with many topics. For future opportunities with this dataset, we believe that we can get more dataset and compare the attitudes of different holiday seasons to find out if there are any significant differences. Also, we can perform sensitivity analysis on Christmas tweets in different years to see how the opinion are changing within a certain time of period. This concludes our presentation. Thanks for watching.